In this video, I'm going to discuss about the interval estimation. From the sample data, an interval is calculated such that this interval includes the true value of the population parameter with certain level of confidence chosen. So hence, this kind of interval is called confidence interval. There are two types of confidence interval that we are going to learn in this chapter. One is confidence interval of population mean. One is confidence interval of population proportion. So in this video, I'm going to discuss the confidence interval of population mean. Then for confidence interval of population proportion will be discussed in the next video. When calculating the confidence interval to estimate the population mean, the interval produced may or may not include the true value of the population mean. For example, this is the population of a random variable x, where the population mean is mu. To calculate the interval, then one sample is selected from the population, and based on this sample selected, an interval is calculated. Let's say the interval is from A1 to B1. So when we look at here, we find that this interval includes the population mean. Then if I continue to do the sampling for the second sample and calculate another interval, and if the interval start from A2 to B2, so again we are confident that this interval includes the population mean. If I continue to the sample 3 and calculate the third interval, but this time the interval starts from A3 to B3. So it is clear that this interval does not include the population mean. And when I continue to the following sample, we find that the interval produced varies from sample to sample. So therefore, the interval is a variable. Here we are very sure that the interval from the first sample and second sample include the population mean, but third sample does not include the population mean. This is because we assume that we know the population mean. But in fact, most of the time for the population, we do not know the true value of the population mean. So in this case, we totally do not have any confidence to say that the first interval and the second interval include the population mean. So therefore, to solve this problem, a confidence level is specified and the interval is then constructed based on the confidence level chosen. The commonly used confidence level is 95%, 98%, 99%, and so on. Actually, any values of confidence level can be chosen. Let's say a 98% of confidence level is chosen, then the interval produced is a 98% confidence interval to estimate the population mean. This confidence interval can be interpreted as there is 98% of confidence that the interval produced contains the population mean. Or we can interpret as 98% of the intervals produced will contain the population mean. Or we can say that the probability that the interval produced contains the population mean is 0.98. When doing the estimation of the population mean, sample mean is used to estimate the population mean, where the sample mean is approximate to normal distribution under central limit theorem when n is large. If 98% of confidence level is chosen, still has a chance to make mistake, that is, we still have 2% of making mistake. So this probability of making mistake is denoted as alpha. Now when we look at this diagram, the probability of making error means the probability that the interval produced does not include the population mean is alpha. Since there are two tails here, so each side the probability is alpha over 2. Then the probability of the interval produced include the population means is in this area, that is 1 minus alpha. So the interval contains the population mean is started from this value and up to this value. So these two values can be found by using the normal table based on the probability here. So from the table, this is the z value that we call it as z alpha over 2. This is the negative z alpha over 2. So therefore, the interval which contains the population mean is the value of z in between negative z alpha over 2 up to positive z alpha over 2. Now I'm going to convert this z score into the x. Since we know that z is equal to bar x minus mu divided by standard deviation of the sample mean. Then I'm going to shift this value. Then I get z times the standard deviation of the sample mean. Next, I'm going to shift this bar x to left and right. Then I get left hand side like this and right hand side like this. Then I change the negative into positive. When I change the negative into positive, this direction will change, and when I rearrange this inequality, then I find that mu is greater than bar x minus z times the standard deviation of bar x, and mu is less than bar x plus z times standard deviation of bar x. So from this equation, we can say that the probability of mu in between these two values is 1 minus alpha. When we change this to percentage, then we can make conclusion that there is this percentage of confidence that mu is between this value and this value. So now as a conclusion, to find the confidence interval of population mean, first step we need to calculate the sample mean by using the sum of x divided by n. Then using this sample mean as the center, we are going to find the lower limit and upper limit, which is the lower limit is x minus z times the standard deviation of the sample mean, and the upper limit is x plus z times the standard deviation of the sample mean. So therefore, this is the confidence interval for the population mean. Now it's time to try some questions. A random sample of 10 fishes is caught from a pond and its length were measured. The results are as follows. The lengths of fishes in the pond are normally distributed with variance 4. Find a 95% symmetrical confidence interval for the mean length of all the fishes in the pond. Interpret your answer. Now, to find the confidence interval for the population mean, first we are going to find the sample mean. To find the sample mean, we are going to find the sum of each observation divided by the sample size. And when we sum up all the measurements, we find that it is equal to 99.4 and the sample size is 10. So therefore, the sample mean is 9.94 cm. Next, we are going to find the value of Z. To find the value of Z, since it is 95% of confidence interval, means alpha is equal to 0.05 and alpha over 2 is 0.025. Now we are going to find the value of Z under alpha over 2, 0.025. And when we look at this diagram, 0.025 is the probability of this shaded region. So means the probability of Z greater than this value is equal to 0.025. And 0.025 is not in the normal table. So we change Z greater than becomes 1 minus Z less than. So therefore, then we simplify, then Z less than this value is 0.975. And based on the normal table with the probability 0.975, this Z value is equal to 1.96. Now we are going to find this value. Since we are given the variance is equal to 4, therefore this is equal to 2. After we have got all this value, now we simply substitute the value into the formula. So after calculate, we find that the confidence interval is from 8.700 to 11.180. Then based on this confidence interval, we are going to interpret. Since in this question, the population mean is about the mean length of the fishes in the pond, so therefore we can say that there is 95% certainty that the mean length of the fishes in the pond is between 8.70 cm to 11.18 cm. Second example. A random sample of size 100 is taken from a population and the data are obtained as follows. Find a 97% symmetrical confidence interval for the population mean. First, I'm going to find the sample mean. Since we are given the sigma x is 108, so sample mean is 108 divided by the sample size 100. That is equal to 1.08. Next, I'm going to find the Z value. Since the confidence interval here is 97%, so the probability is 0.97. So means alpha is equal to 1 minus 0.97. It is 0.03. Then alpha over 2 is 0.015. And from the normal table, probability Z greater than 2.170 is equal to 0.015. So therefore, the Z value is 2.170. Then after that, in this question, we found that we are not given the population variance. If the population variance is unknown, then we are going to find the unbiased estimate of the population variance. And I'm going to use this formula because in the question we are given that the sigma of x minus bar x squared is 74.8. Then when I substitute the value and I calculate, and I found that it is equal to 0.75556. And therefore, the sigma h is equal to square root of 0.75556 and it is equal to 0.86923. Once I have got all the information, now I'm going to substitute all the data into the formula. So after substitute and I calculate, then this is the 97% symmetrical of confidence interval for the mu, that is from 0.8914 to 1.2686. Next example. The scores of an IQ test is known have a normal distribution with mean is equal to mu and variance is equal to sigma square. A random sample scores of 68 people who have taken the IQ test was selected, and a 98% symmetrical confidence interval worked to be 88.2 to 102.8. Find the sample mean and the standard deviation. From the theory, we know that the sample mean is the midpoint of the confidence interval. So since we are given the confidence interval, so we can calculate the bar x, that is the sample mean, is equal to midpoint of the interval, that is 88.2 plus 102.8 divided by 2. So therefore, the sample mean is 95.5. And since the confidence level is 98%, that is 0.98, so therefore alpha is equal to 1 minus 0.98, that is 0.02. Alpha over 2 is 0.01. And from the normal table, the z value is equal to 2.326. And from the interval given, we know that 88.2 is the lower limit and 102.8 is upper limit. And in order to find the sigma, I can use either the lower limit or upper limit to do the calculation. So here I choose the upper limit. That is, the upper limit is equal to 102.8, and I substitute the bar x, 95.5, the z value and the sample size. Then after calculate, I find that the standard deviation is 25.88. Next example. A machine produces elastic bands with breaking tension is normally distributed with mean 45 Newton and standard deviation 4.36 Newton. In order to test whether there is a change in the mean breaking tension, a random sample of 50 was tested and found to have a mean breaking tension of 43.36 Newton. Find a 95% confidence interval of the population mean breaking tension based on the sample mean, assuming an unchanged standard deviation. Hence, determine whether there is a change in the mean breaking tension. From the question, we are given that the mean breaking tension is 43.36, that is bar x. Then under 95% confidence level, alpha is equal to 1 minus 0.95, that is 0.05, and alpha over 2 is 0.025, then the z value is 1.96. And we are also given the standard deviation is equal to 4.36, with the sample size is 50. So therefore, to find the 95% symmetrical confidence interval for the population mean, now I'm going to substitute all the values that I have into the formula. So after calculate, the interval is from 42.25 to 44.67. And based on the result, we are going to determine whether there is a change in the mean breaking tension. The original mean breaking tension given is 45 Newton. And when we look at the estimated confidence interval, we found that the confidence interval does not include the value 45. So therefore, 45 is rejected. So conclusion, at 95% confidence level, there is sufficient evidence to conclude that there is a change in the mean breaking tension.